Hi, my name is Daniel Otamelum, and this is Project 1.2, the analog oscillator. This circuit consists of a 9-volt power source, two 1 kilo ohm fixed resistors, two 10 kilo ohm fixed resistors, two 5mm yellow LEDs, two 100 microfarad polarized capacitors, and two 2N3904 NPN transistors. Capacitors are made of two conductive plates of opposite charges separated by a dielectric, which is an insulator. The space between the plates creates an electric field where energy is stored. Transistors have three legs, the emitter, base, and collector, and act as switches in this circuit. The analog oscillator, also known as an astable multivibrator, fluctuates between two quasi-stable states. These states are temporarily stable, causing the oscillation of the LEDs. When the circuit is turned on, the first capacitor charges to roughly 8 volts on its positive lead and 0.7 volts on its negative lead. At 0.7 volts, the capacitor discharges and turns on transistor Q2, which connects the yellow LED to ground, and this turns on because there's a voltage difference. At that point, the second capacitor charges to 8 volts on its positive lead and 0.7 volts on its negative lead. When this discharges, turns on the first transistor and connects the first LED to ground, which turns on the LED. But the 8 volts on the positive lead of the first capacitor then gets pulled down to 0 volts since it goes to ground. And since the internal charge cannot change, that means the 0.7 volts on the negative lead now becomes negative 7.3 volts, which turns off this first LED. The cycle repeats and the oscillation of the circuit happens. The PCB version of the analog oscillator introduces a few ways to power the circuit. First is the 202AH King's power jack. Second of all is the Schroeder power jack. And the terminal block allows you to run wires to a power source. Finally, the slide switch turns on and off the circuit. My name is Daniel Otamelum. Thank you for listening.